So let's go back to our random variable y, which was normally distributed with mean 5, standard deviation 4. Now let's calculate what's the probability that that a realization of y lies between 3 and 7. Okay? This is the probability that y lies between 3 and 7. Okay? Again, convert this to a standard normal random variable. Convert this value of 3 down to something. 3 minus mu over sigma, which is negative 0.5. Okay, this value of z associated with 3, negative 0.5. That is, 3 lies a half a standard deviation away from 5. And let's convert this value, 7, down here. That's 7 minus 5, which is 2 over 4, which is 0.5. So we want this area right here, centered about 0. And this probability is the probability that z is between negative 0.5 and 0.5. Okay? These two areas are equivalent. So now we just need to go look up in the lookup table. This area, that area is the same as this area, okay? Because this is a symmetric distribution. The area between 0 and 0.5 is the same as between 0 and negative 0.5. So if we go to our lookup table, go down to the 0.5 row over to 0.00 column, we should get that this area is 0.1915. Okay? So that's 0.1915. This is 0.1915. So if we sum those two values together, the probability that y is between 3 and 7 is 0.1915 times 2, which is 0.338. Okay? So the probability that random variable y lies between 3 and 7, 0.338. Roughly 34% of the realizations of y will lie between these two values. So one last problem for our normally distributed random variable y with mean 5, standard deviation 4. Let's say we want this probability. The probability that y is less than 4, or the probability that y is greater than 10. Okay? What's the probability that y is less than 4? Be right about here. Okay? Or the probability that y is greater than 10. Okay? So we want this area and this area. Again, all we have to do is convert this to a standard normal distribution. Okay? And this value 4 would be somewhere around here. Okay? We need this area. This area is equivalent to this. If we just convert this to the number of standard deviations away, 4 lies from 5. That is 4 minus 5 over 4, which is negative 0.25. Okay? Again, 4 is a quarter of a standard deviation to the left, the negative side, to the left of mean 5. And up here, we just got to convert this value. Down here, that's 10 minus 5 over 4, which is 5/4 or 1.25. Okay? So the probability that y is less than 4, union with the probability that y is greater than 10, is equal to the probability that z is less than negative 0.25, or probability that z is greater than 1.25. Okay? So we just have to find these two areas in our lookup table. We're not going to be able to find those directly, but it shouldn't be too hard. Here is 0. Here is 0.25. And we need this area right here. Okay? That's this sliver here. Okay? If we go look that up, that is going to be 0.0987. Okay? So that gives us this little sliver here. Now let's go look up this little sliver here between 0 and 1.25. Between 0 and 1.25. Okay, this area, if we go look up this in the z table, that's row 1.2, column 0.05, we should get 0.3944. Okay? So if we add these two together, that gives us this area. Okay? The complement of this area is everything else. Okay? So if we sum these two up, the probability that z is between negative 0.25 and 1.25 is 0.0987 plus 0.3944. Okay? If we take the complement of that, we get the area that we want. Okay? So 1 minus this is 1 minus this here, and that number is 0.5069. Okay? So the probability that z is less than negative 0.25 and greater than 1.25 is equal to the probability that y is less than 4 or greater than 10, and that probability is 0.5069.